Hello, good morning, students. So today we'll start a new chapter, linked lists and stacks. This is from the unit data structure. So if you have watched yesterday's video link, I'm sure that by now you will have understood the uh, definition of linked list and the difference between linked list and arrays, and how the pros and cons of linked list and arrays, right? So you saw that array is one way of storing the data through data structure, and linked list is another way. So you can see that here array is a static data structure. So array is a linear static data structure. So because array stores the data sequentially, so the array elements are means like it starts from the array index 0 1 2 3, right? So when the data are entered, the data are entered according to the array elements in a sequential way. Also, when the data are stored in the memory location, the memory locations in an array are also in a sequential manner stored. Like if suppose the first array element is stored in 0, then in index 0 the memory location is 101. Then array element 1 will be suppose like 102. Array element 2 will be 103, like that, right? So the memory location is also in a sequential manner, systematic, right? Step one after the other. But the disadvantage of using an array is in terms of wastage of memory space, because like if you declare an array of size 50, if the range of the array is 50, and you use up only 10 elements, if you only declare 10 elements, so what happens is that 40 of the memory space becomes wastage. So the size of the array, when you declare an array uh, like array of size 50, right? So when you declare, you must always declare an array, right? So when you declare the array of size 50, then then what happens is that the compiler allocates mm, memory space for 50 array elements, right? But if you use up only, if you declare only 10 array elements, then what happens is that 40 array elements memory space goes to waste. Now in terms of small programs it is okay, but when you're dealing with real life problems, real life program solutions, then what happens is that if suppose you declare the array size as suppose like 1000, then in that case you see, and if you use up only 100, then you see that 900 memory space goes to wastage, right? So that is not acceptable. Okay, so in also that in array insertion and deletion requires lots of shifting, so it is difficult to insert or delete items in an array. That is like if you have watched a video tutorial, then you must have understood that, because like in array the data are stored sequentially, data are inserted in a sequential manner. Also like suppose like if you have the array elements starting from ranging from number 1 2 3 4 5 and 6 is missing, and 7 8 9, like that, right? Now if you have to insert the value 6, then since the arrays are in sorted format, so you have to enter number 6 between 5 and 7, right? So what will happen is that 7 has occupied the place of 6. So when you enter the value of 6, then 7 will shift from 6 to 7. Then again 8 will shift from 7 to 8. Then 9 will shift from 8 to 9. So you can see that the numbers after 6 has to shift one place again. So that creates a problem. So that slows up the process. Again, when you have to delete, suppose you have to delete 6, again 7 has to take the place of 6, 8 has to take the place of 7, 9 has to take the place of 8, right? So that becomes unacceptable. So that problem is solved using linked list, sorry. So linked list consists of a series of nodes which are not necessarily adjacent in memory. So that means in linked list, the data are stored randomly. The memory locations are also random. But how do you, uh, how is it able to link all those data together? That is, okay, each node contains the element and a pointer to a record containing its successor. Okay, that is this. Here, that's how you get the name linked list. Okay, so you can see here that this is the data, that is red, green, yellow and blue. Okay, so in a linked list what happens is that you use two array elements. In an array you use only one array elements to store the data, and then since the array in an array since the array elements are stored sequentially in order starting from array index 0 1 2 3 4 5 6 7 like that, and the memory locations are also in a sequential manner, one after the other. So you don't need to search the data like that, because the data you can find in a sequential manner. So it does not need the address of the next, because the next data value, since the values are stored are in sorted format in an array, so the next increasing number will be found in the next element, right? After 1, if you're searching for 2, 2 will be found after 1, like that, right? So but in a linked list, what happens is that this is the main disadvantage. In a linked list, for every data, you require two array elements. One element for to store the data, and another element, the address of the next data. So if suppose this element, this data is stored in location 2, okay, so 2, the address of this 2 will be stored in here, which will point to this address, address. Clear? So what happened in linked list is the address of the next data is stored in the previous link. There. So also you must have from the tutorial you must have understood the concept of the first node or the head node, okay, and the start node, and the concept of null. So you can see that in here after blue there is no more data to be entered. So here the last link, okay, will contain what is called as null value, or it contains zero value, because it does not point to any other address. And in a linked list, always it starts with the head node. So it starts with the head node, and the head node should have the address of the next node. So that's how you link the data in a linked list. So it is a must to have the first node or the head node or the start node. Okay. So uh, now what happens is that in a linked list, like I said, okay, the data may be in random memory locations. So all the linking is done with the second array element. Okay, so that in a linked list it use up much more memory space. So that is one advantage in array. In array, you use only one array element, but in a linked list, you use two array elements. However, the main advantage in a linked list is, since the data can be stored randomly, the data can be stored randomly. Okay, and in all, so the data may be stored randomly, and you can easily find the data because you have a second array element which points to the address of that data. Got it? So now representation of linked list in memory. Now to represent the linked list in the memory, you have a pictorial diagram. Okay, so you can see here that this is the order of the linked list. Okay, 1 2 3 4. You can see that number 1 is empty and number 8 is empty, right? So this is how the so in the first array element, the data are stored, and this is the order of the array element, right? And this, in the second array element, you have the address which points to the next data. So in this diagram you can see that the color combinations are different, and then the address is also stored randomly. It is not like 1 2 3 4, but 4 2 6 0 9, like that, right? So here you can see that in this picture you can see that data 2. So this is the array name, right? So this is the variable name. So here the index is 2, which means that in index 2 the color cyan is stored, right? So now how is it linked to the next color, that is green? Now you can see that this color is stored in this index 2, but green is stored in index 4. Normally in an array it will move from this color to this color to this color, and the memory location will also be supposed like 2 3 4, but now you're moving from this color to green, cyan to green, right? So how is it able to jump from this element to this element? So that is by the memory location, because you can see here in this is the second box, okay, this box. So in here you can see that the link address of this that is linked to the address is mentioned of the next data, that is 4. So 4, so this is the address of this color green, so that's why it's mentioned here. So from here it will go to here, and in green the next address of the next color is mentioned, that is 6. So it will move from 6, which is this Maui, right? And in the next, it is the next link is given, that is 9. So that is 9, so that is blue. So you can see that it is jumping from one order to another. Now if suppose you have to enter the data in the linked list, then you need another variable called as avail. So this avail will point to the unused memory space in the cells memory block. Okay, now in this particular example, you can see that the first block, or the head block, or the head node, is the color brown, that is array element number 3. Okay, and then so what happens is that when you have to insert a new color, suppose like here in this case, that is violet, right? Now you want to insert, suppose like a violet in here, then what will happen is that the avail variable, okay, or the avail variable will search for the empty link, for the empty array element. So it finds it in, suppose like in 8. Now in here in this particular example it is given as 8, so it will be entered in between the red and blue. So violet is entered in between the red and blue, as you can see, right? So but it may be that, okay, it may be entered in this also, number 1. So what happens is that once this is entered and stored in this array element number 8, okay, then it will point to, okay, it will then when you have to insert the next number, or the next value, then there's only one memory location free, right? So it will be entered in here. As you can see that after this color, okay, it points to the next array element address, that is 0, right? So that means after this color, okay, after this color there is no more color to be added, so that's why this is 0, which means null. Okay, so this link is the last link, which becomes 0, that is null. As you that means here if violet is written, okay, this will be the null value, that is 0. Clear? But if suppose you after this you want to insert another color, so because there's another empty array element, right? So what will happen is that here the address here will be 1. Okay, here the address here will be 1. Suppose here you are inserting the color, suppose like black. Now black here, in this case the link will be 0. So because this is the last color and this is the last link, so this will not point to any other address memory location. So that's why here it will be 0 and here it will be 1. Okay, so I hope from this pictorial diagram you have understood how you can insert the data in the linked list, okay, into the memory, and how it is represented in memory. Okay, now when you have to use this declare this linked list, okay, you use the structure method. Okay, so as you are already familiar with the concept of structure, okay, what happens is that here the data type and the data represents the variables, that is this, okay, where you'll be entering the values, storing the values, and evaluating on that. Okay, this node link means the second array element link, okay, which will point to the address. Okay, and this node asterisk list represents the structure variables that will be declared, through which you'll be able to access these members of the structure. Okay, so you can declare as much node list as you want, 2, 3, 4, through which you'll be able to access these members. Clear? So as you can see here, the linked list is a dynamic data structure. Okay, so array is a static data structure and linked list is a dynamic data structure. I'm sure that you have understood the difference between that in the video tutorial, right? Okay, because here in a linked list, okay, the data are stored randomly and you can access it randomly, provided there is a head node, okay, and the last node is represented by the null, okay, and then there is an eval node which will point out to the available array elements in the linked list, okay, to the empty elements in the linked list through which you can store insert the data. And I'm sure that in the video tutorial also you have understood how easily you can insert. So as I've explained here, if you're inserting a new value, suppose like violet, this becomes the last link. But if suppose you're inserting another value, suppose like black, data value black, right? Now since this data is entered here, it is also a color, so it has to be linked with all of this, right? Since this is the last data, suppose like black, so the second last data should link with this, so that's why the address here will change from 0 to 1, and then here the address will be, the link will be 0 because this will contain null address. So similarly, when you have to delete also, okay, so if you delete this, then this will become 0, or if you delete this, okay, the link before that will be replaced by a different address. Got it? Okay, so when you are using the structure program, okay, and when you have to create the linked list, okay, so the structure list will be created like this. These are the structure variables, that is like n1, n2, n3, right? And how do you link with the data? By using the dot operators, like node1 dot data, okay, and this node1 dot link, okay, see, node1 dot next, and this ampersand that you have used in function chapters also, right? So this represents the address of the next node, right? So when you come to the program part, okay, you'll get a better understanding of it here. So I'll stop here for today. In the next video, I'll explain the concepts of traversal of linked lists. All right.